okay? On the right-hand side, in the exact plane, the equivalent length is longer. The equivalent longer means what? Less resistance to buckling. But the second moment of area make it more resistant to buckling. Okay. So in this context, now when we want to make both sides, okay, having the same or most efficient design, the most efficient design happen when PCR in the XY plane must be equal to PCR at the XZ plane. So when this is the case, both plane can withstand the same amount of PCR before buckling. Okay, before buckling. Okay, so that's why this question is it really enhance your understanding now. Okay, the previous example, equivalent length are the same. Okay, only the second moment of area changes. For this example over here, both equivalent length and the second moment of area are different. Okay, so for this case, we just need to equate. So pi squared E. So for this case, we are going to use IZZ. Okay, so IZ is equal to BA cubed, right? Divided by 12. And the equivalent length is equal to 0.7 L squared. Okay, so that is one side. And then on the other side, this is equal to pi squared E. And then we have AB cubed. And then over 12. No, not the whole thing over 12. And then over here, we have 2L squared. Okay. So let's see what we can get rid. Okay. We can get rid of pi. Oh, sorry. We can get rid of pi over here, get rid of pi squared. We can get rid of E. You can get rid of E. You can get rid of 12. 12. You can get rid of L. L. You can get rid of one of the B. This will become squared. You can get rid of one of this, and this will become squared. Okay. So from here, what we have left is A squared. Okay, A squared over 0.7 squared. And over here, you have B squared over 2 squared. Okay, so that's what we are left with. Okay, so from here, I like to copy. So now we have this relationship over here. So we have A squared over B squared is equal to 0.7 squared divided by 2 squared. So we can have A over B squared will be equal to 0.7 squared divided by 2 squared. 0.7 squared divided by 0.7 squared divided by 2 squared is equal to 49 over 400. So therefore, our A over B ratio is 7 over 20. Okay, our ratio is 7 over 20. Okay, so basically A is equal to 7 over 20 B, or B is equal to 20/7A. So at this ratio, okay, buckling or the critical load or buckling in the XY, and I could not remember what is the other plane, XY and YZ plane are the same. So this is how we define as the most. Okay, this is how we define as the most efficient. Okay, so now part B. So now we have formulated everything already. Okay, now we have formulated everything. So part B. Okay, so part B, we are given some values. Okay, so given, okay, given that the L is equal to 20 inches and the Young's modulus is equal to 10.1 times 10 to the power 6 psi. And we are also given the P applied is equal to 5 times 10 to the power 3 psi. And we are also given that the factor of safety is equal to 2.5. Okay, so this is what has been given to us. So now we start putting in numbers. Okay, we start putting in numbers. So we want to find what we're trying to find, A and B. Okay. Given the loads that are, or given the condition or the properties that are given or that are given to us. So we know that the factor of safety is equal to P critical over P applied. Okay. So from here, the factor of safety is equal to 2.5, or is equal to, or I'm going to write this. So this is 2.5, which is equal to P critical. And then we have to divide this by 5 times 10 to the power 3. So from here, our P critical will be equal to 2.5 times by 5 power 3 is equal to 1,000 or 12,500 pounds. Okay. So this value over here will be equal to our PCR in our XY plane. And this is also our PCR in our YZ plane. Okay. So I'm going to do both. And why I want to do both, to show you that both the answer should be and has to be the same. Okay. So now we are going to consider. So I develop the what plane first? I develop XY plane first. So consider XY plane. Okay. So the formula that we're going to use is PCR XY plane. This will be equal to pi squared E IZ over, so at the XY plane, the equivalent length is 0.7 L squared. Okay. So this will be equal to 12500 pi squared Young modulus is 10.1 times 10 to the power 6. IZZ, let me see what's IZZ. IZZ, BA cube over 12. And then we have to divide this whole thing by 0.7 times by the length given to us is 20, and the whole thing squared. I don't like to write this. I'll write something else. I don't feel nice. So 0.7, 20, and the whole thing squared. Okay. And then we can also note that B is equal to what? So B is equal to 20 over 7A. Okay. B is equal to 20A over 7. So when we put into that, we have 12500 will be equal to pi squared, okay, 10.1 times 10 to the power 6. Then we will have 20 over 7 multiplied by A4 now, because that is replaced by the B. And then the whole thing divided by 0.7, 20 squared, and then we have 12 down here. So we put everything together. A4 will be equal to 12500 times by 12 divided by 0.7 divided by 0.7 divided by 20 divided by 20 divided by pi squared divided by 10.1 power 6 divided by 20 over 7. We get 2.667 times 10 to the power minus 6. And then we have our A, so power by a quarter is equal to 0.8. I think 20 over 7. Wait, 12500 times by 0.7 times by 0.7 times by 20 times by 12 divided by shift pi squared divided by 10.1 power 6 divided by 20 over 7 is 5 point. Wait, I get 5.20. Okay, I need to check on something. I'm not getting my right numbers. What I propose that y'all go for a 10 minutes break and you come back. Okay, go for a 10 minutes break.